Hey y'all. Today we're going to be starting with right triangle trigonometry. We're going to be doing it today, tomorrow, and the day after that. So, trigonometry is the branch of mathematics dealing with the relationships between the sides and angles of triangles and with the relevant functions of any angles. So, it deals with how are our angles and our sides related in a triangle. So, there are three basic trigonometric ratios that we need to know. The first one is sine, the second one is cosine, and then the third one is tangent. So sine, cosine, tangent. So let's start with sine. So I'm going to draw right triangles in all three of these. And I'll go ahead and do that for the rest of them. Okay, and we're going to have some angle. Okay, so this angle is a circle with a line through it. That angle is called theta. So sometimes this angle may be represented with a variable, but I'm going to use theta, which is a Greek symbol, a Greek letter. So again, it's a small circle with a line with it, and it's called theta. And theta is an angle. So let me write that somewhere. So this is the symbol that I'm drawing, a circle with a line through it. That symbol is called theta. And it's an angle. So sometimes you'll see theta, this little thing, but it's an angle. And then other times, if we jump down here to the examples, you'll just see the variable. So I just want you to be comfortable. You might see X, you might see Y, or you might see this Greek symbol theta. It just means it's an angle. So let's start with sine. I'm going to also use the abbreviations of these. So S-I-N-E is sine, but we abbreviate it S-I-N. The sine of theta is opposite over hypotenuse. So opposite over hypotenuse. So what does that mean? That means if I have, that means wherever my x is, or theta, if I go directly across from that, that's the opposite side. So I'm going to go directly across from this. That's my opposite side, that little red line that I drew in. The side underneath it or beside it is your adjacent side. And then the side directly across from your right angle, that's your hypotenuse. So let me draw that in. I'll draw that in green. So let's go through the sides of our triangle again. Wherever your angle is, go directly across from that, and that's your opposite side. So here I am. I'm going to go directly across. That's the opposite side. Find your right angle because we're working with right triangle. So find your right angle, go directly across from that, and that's always your hypotenuse. And then the other side is called the adjacent side. So my definition for the sine of theta is opposite over hypotenuse. So whatever these values were, we would put the opposite number here, the hypotenuse here, and that would give us our answer. Now let's take a look at cosine. The abbreviation for cosine is COS. Our definition for cosine is adjacent over hypotenuse. So let's label that in our triangle. Again, this is my reference point. This is where I'm starting from. So my adjacent side is actually here. That's my adjacent side, A for adjacent, and my hypotenuse is still in the same spot. So go directly across from your right angle. That is your hypotenuse. Directly across from your angle measure is the opposite side. And then the side that's underneath the angle, right beside it, that is your adjacent side. So cosine is adjacent over hypotenuse. And our last trig function is the tangent. So tangent is T-A-N. That's my abbreviation for tangent, T-A-N. And our definition for tangent is opposite over adjacent. So let's fill that in our triangle. Wherever your angle is, go directly across from that. That's always your opposite side. And then the side touching it is our adjacent. So that is our definition for tangent. So these are my three main trigonometric ratios. We have sine, which is opposite over hypotenuse. We have cosine, which is adjacent over hypotenuse. And we have tangent, which is opposite over adjacent. Now, there is an acronym that'll help us remember it. So it's SOHCAHTOA. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So if you remember SOHCAHTOA, that's how you say this. SOHCAHTOA. So if you remember that, that'll help you kind of shorten what you need to remember so that you'll know that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Another way to help you remember is some old hen caught another hen taking oats away. If you want to make up your own kind of acronym for what the S, the O, the H, etc. stand for, knock yourself out. Just make sure you find some way to remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. It's just like how we remember PEMDAS. So we remember that as an acronym. Please excuse my dear Aunt Sally. It's the same thing, just a shortened way to help us remember what they stand for. All right, by all means, let us jump into some examples. So example 1, use a trigonometric ratio to find the value of x in each right triangle. So we're going to go through for each of these, and we're looking for what does x equal. So you first want to figure out what do you have. So you want to label the different sides of your triangle. So step 1, label the different sides of your triangle. 34 degrees is what I'm starting with. Go directly across from 34 degrees. That is your opposite side. So I'm going to put an O for opposite. Directly across from my right angle is my hypotenuse. So I'm going to put H for hypotenuse. Now, if I slide this back down, which one deals with O and H? So which one of these, sine, cosine, or tangent? Which one deals with O and H? Hopefully you guessed sine. So sine deals with O and H, opposite over hypotenuse. So my relationship that I set up is the sine of 34 degrees, because that's my angle. My angle measures 35, is equal to the opposite side, which is x, over my hypotenuse, which is 10. Now, we need to solve this equation for x. The opposite of dividing by 10 is to multiply both sides by 10. So I'm going to multiply this side by 10, and I'm going to multiply this side by 10. So that's going to give me 10 sine of 34 is equal to x. So the opposite of dividing by 10, we multiply both sides by 10. The 10s on this side cancel out. So we're left with 10 times the sine of 34 degrees is equal to x. So let's put our degree mark up here. Now we can type this into Desmos. So let me show you how to type this into Desmos. So when you open up a Desmos tab here, since we are working with degrees, go to this it looks like a tool kind of thing where it says graph settings. Click on that. And you want to go down to the bottom and change it to degrees. So again, where I'm hovering at here, that's your graph setting. You want to click on that, and you want to hover down to degrees. From here, I can just type it in. So we're typing in 10 times the sine of 34, and that is our answer. So 10 times the sine of 34. So that gave me 5.59. So I'm going to round to the nearest hundredth. So that's going to give me 5.59 as our answer. So if I go back to my sheet here that I'm working with, I typed that in Desmos, and it gave me 5.59. So you can type in your answers in Desmos. Make sure you put it in degrees. Next, B, let's label the different sides of the triangle that we know. Directly across from the right angle is always your hypotenuse. So this is H. So if you need to kind of maybe draw a line so you know that you're going directly across, and I could have done that same thing with this one as well, in case you're having trouble recognizing the opposite, adjacent, and hypotenuse. So directly across from here is my hypotenuse, and this side is my adjacent because it's beside the angle. So this is my adjacent. So which one deals with adjacent and hypotenuse? You guessed it, is cosine. So my relationship here is going to be the cosine of 28 degrees is equal to my adjacent side, which you don't know is x, over the hypotenuse, which is 15. We need to solve this equation. The opposite of dividing by 15 is to multiply both sides by 15. So this gives me 15 cosine 28 degrees is equal to x. So 15 times the cosine of 28 degrees is equal to x. I will type this in one more time just to make sure you're good when you're in Desmos. So let me get rid of this one. It's already in degrees because I typed in the first one. But you would type in 15. I literally typed in COS, 28 degrees, and we got 13.24. So that will be our answer for this, 13.24. So I will write that down. Ta-da. All right, C, let's label what we know. This is 50 degrees. Directly across from that is the opposite side, so I'm going to put an O. This 6 is beside the angle, so this is my adjacent. So which one deals with opposite and adjacent? That is tangent. So our relationship that we set up is the tangent of 50 degrees is equal to the opposite side, which is x, over the adjacent side, which is 6. The opposite of dividing by 6 is to multiply both sides by 6. So this gives me 6 tangent 50 degrees is equal to x. And I won't type this in. I trust that you can just leave it in degrees. You would type in 6 tan 50 degrees, and it will give you 7.15. All right, let's try some more. D. So we're on 1D now. Label the different sides of your triangle that will help you out immensely. So this is 42 degrees. If I go directly across from that, it looks like I have the opposite side. And this is my right angle. Directly across from that is always our hypotenuse. So which one deals with opposite and hypotenuse? That's the sine. So we have the sine of 42 degrees is equal to our opposite side. In this case, my opposite side is 6. And my hypotenuse is x. Now, I need to solve this equation. I still can solve it. No biggie, I can solve it. So I'm dividing by x. I need to multiply both sides by x. So I'm going to multiply this side by x. And I'm going to multiply this side by x. Okay. So I multiply this side by x. These x's cancel. And now I have x sine 42. So x sine 42 degrees is equal to 6. Now we got one more step. I'm not trying to get 6 by itself. We're trying to get x by itself. This is x times the sine of 42 degrees. The opposite of multiplying is to divide. We're going to divide both sides by the sine of 42. So x is equal to 6 divided by the sine of 42 degrees. Again, we can type this in Desmos. You would type in 6 divided by the sine of 42. So I will show you a division one just to make sure we're good. So we're typing in 6 divided by the sine of 42. 6 divided by sine of 42. And I'm around to near 100, so I got 8.97. So if I go back and write that answer on my paper here, I got 8.97. E, same thing. Step 1, label the size of your triangle. So 30 degrees is where I'm starting from. That's always going to be your reference point wherever your angle is. If I go directly across from that, looks like I got the opposite side. And the adjacent side is given. So which one deals with opposite and adjacent? That's tangent. So we have the tangent of 30 degrees is equal to the opposite side over the adjacent side. The tangent of 30 degrees is equal to the opposite side over the adjacent side. We go through and solve this. We're going to multiply both sides by x. Okay, I multiply both sides by x. Then the opposite of this is to divide. So x is equal to 12 divided by the tangent of 30. Okay. We typed that into Desmos and it gave me 20.78. And last one, looks like I am giving the adjacent side. So this is 64 degrees, so I have the adjacent side. That's A for adjacent. Directly across from my right angle is always the hypotenuse. So which one deals with adjacent and hypotenuse? That is cosine. So our relationship is cosine 64 degrees. Our definition is adjacent over hypotenuse. So my adjacent side is x and my hypotenuse is 18. We're trying to get x by itself. The opposite of dividing by 18 is to multiply both sides by 18. So that's going to give me 18 cosine 64 is equal to x. We type that into Desmos, you get 7.89. So make sure you come up with some way if you want to remember SOHCAHTOA. So SOHCAHTOA, or if you want to remember the some old hen caught another hen taking oats away, just make sure you remember some way to help you with your definitions. In the next video, I'll show you how to find a missing angle value.